Hey, Algebra 2. Let's see. This is day one, and here's the homework problems for this. It seems like a lot, but remember, if you were in class, we also got head starts on nearly all of these chunks here. So there should only be a handful of problems left for you to check from doing independently. But in class, we had both a notes packet and then we had a homework packet. And so that's the what I'm referring to. Now this was the packet that started with lessons 1, but it continued on until we got through lessons 5 and 6. Now what are these? Remember that these are Algebra 1 skills that are in the 8th unit, the very last unit of Algebra 1. And typically that gets, in the past few years, that's gotten cut for time. You would just run out of time at the end of the year. There's not enough time to get to this. So, here's the thing is that, you're older and we have done some pre-teaching of this stuff. Now we're coming back together and doing a series of lessons that have a chronological order where there is notes and there is homework practice for each one. Practice makes perfect. So I really hope you're dialing in and doing these. Okay, let's go over, we're gonna go over the notes first and then we'll go over every problem in the homework. So this is going to be a long video because of that. So, hey, we know that we can take something in factored form. We can turn it into standard form by using that area model. However, we are trying to move away from that area model. So if you were in class, you know that we were trying to not do this, but to do this double distributive property. Take the x times this and the x times that, and then the 3 times this and the 3 times that to get those 4 parts. The same 4 parts that we would get if we did this little table method. And then combining like terms. We want to go straight from this to that answer, to this simplified answer, because these combine, 5 and 6 combined to make 11. So that's what we were doing down here. There's no table, but we were learning how to do that double distributive method, okay? And then we're doing the same thing here. There's only one thing to distribute, so that x gets distributed to both parts. Again, you can pause the screen for this. Now, in the tradition of teaching math, this is known as the FOIL method, that you multiply the first terms, F, the O, outer terms, first, outer, inner, last. First, outer, inner, last terms. So this is in the parentheses, the A and Z are the first, and B and D are the last terms in those parentheses. So that, there you go. And then you get the overall inner terms, overall outer. I call this the double distributive method. Rather than learning a new thing, you know how to distribute. So we're just doing it twice, and we get 4 sets of answers. Okay. So again, it's just a more complete understanding of how we're doing this algebra. We're trying to get away from using these. Okay, so we're trying to get away from using those. Another part was also identifying in a standard form equation the term. All right, so the coefficient in front of the x squared is called our a term, and the coefficient in front of our x is called our b term, and then the constant that doesn't have any x next to it is our c. I think I'm just gonna let that ring. So so this 5, that's with the x squared, that's our a term, the 9 and the negative 15, and then x squared here doesn't have a number in front of it, so it has a invisible 1 in front of it, and it doesn't have a term with an x in it, so it has a 0 for that part and a negative 1 here. Okay, so as we are reviewing the notes, now I want to we'll review this part again. We were also seeing how can you take this and not use that table to factor it, to go from standard form to factored form, and that's where we're looking at, well, what's going to multiply to make this first part, and what could multiply. We make a list of possibilities to equal this last part, these terms here, but also add up to this 14. And then there's some nice ones like this where there's no middle term. So these numbers must have to be opposites to multiply to make a negative, but also add up to nothing. So, all right, let's see what that looks like in the homework. So, all right. 4.5 minutes in, here we go, starting this. So based on the information here, what is the factored form of this? The factored form, it looks like that. So it's the stuff on the outside. So we would have an x plus 6 and an x plus 3. Doesn't matter which one we write first. The standard form is what's on the inside. Well, an x times an x would make an x squared. We would have 6 x's. So x squared, 6 x's, 3x, and 6 times 3